Okay, important survey. Quick show of hands. How many people have seen the movie The Terminator? Wow. How many people have not seen the movie The Terminator? How many people don't raise their hand no matter what happens? Gotcha. So, the idea, I guess, if you wanted to think about, The Terminator is really a story about ideas. And the idea is, or the key idea is machines get smart, which is something that I think that we all need to be worried about. And I think that the best, it's an idea that gets revisited again and again in science fiction. And the best, in my opinion, iteration of that idea is in a now series, I guess, of books by Vernor Vinge, including A Fire Upon the Deep and A Deepness in the Sky. If you've not read Fire Upon the Deep and Deepness in the Sky, you should go out and get them. You might even set aside your George R.R. Martin stack of books in order to read these books first. Also, the third book in the series is just out in hardback, sitting next to my bed. And there's a couple of really cool ideas in the series. The first one is the notion of the zones of thought. So there's this idea that the capability of intelligent systems is limited by where you are in the universe. And so we happen to live in the zone of the universe where thought is fairly limited, which I notice every day as I interact with people. And that travel is limited to the speed of light. But there are other places in the universe where those limitations do not hold, and there are what, by our standard, would be hyperintelligences. And it's a great plot device for explaining why the hyperintelligences haven't come to visit us yet. And we actually have no way to measure. I think this is an unprovable conjecture at this point, right? Could be the case that there are physical constants about computation and the laws of physics that are not actually measurable from here because we're not there. And so I'm actually pretty worried about this. I've spent a fair amount of time considering this. My kids are like, Dad, why do all the other kids' parents, worry about, income taxes and you're worried about that the sun's going to burn out or, these kinds of problems. But I think at least some people have to, take the long view and worry about these kinds of things. But the thing that I want to say here is that another key idea in the book is that there are people who have a cavalier attitude towards controlling intelligences that we might discover or unleash. And so a lot of the problems in the story happen because some arrogant humans awaken a thing that's called the Blight, that is a hyperintelligence and is dedicated to, among other things, human-scale evil, which is kind of a plot device. It's difficult to understand why it would really matter that much to the Blight. But it's important for us to think about, because when I started using Clojure, I thought, oh crap, we're like that much closer to some piece of software that somebody wrote waking up, right? We have a limit. I certainly, whenever I see Rich write anything in Clojure that's longer than 1,000 lines, he has to cut it and break it into pieces so that it doesn't wake up and become sentient. And the important thing here is that a few dedicated fighters are out there making sure that we have a safe place to sequester these intelligences when they wake up. And this next talk, that's what this is about. Anthony is taking a sort of easy pitch with this, that this is just about Clojure and IRC bots and so forth. But actually, he is the first of a generation of fighters who are protecting us from the machines. So without any further ado, this is Anthony Grimes, and he's going to be talking to us about Clojail.
This actually feels pretty good. I feel like God. Everybody's in front of me. So I'm Anthony Grimes. I've been a Clojure programmer for around 3 years. I wrote Clojure, tryclj.com, except for most of the JavaScript, the design, and pretty much everything else that matters. I'm writing a book called Meet Clojure. It's an introductory text for people coming from pretty much any language, as long as they programmed in at least one language. It should be out by November of 2020. I'm the youngest person in this room. I don't even have to ask people. Obviously, I'm 17. And I'm a Stuart Sierra groupie, obviously. Big fan. So, code is dangerous. If code wasn't dangerous, you wouldn't be able to read or write to the file system. You wouldn't be able to talk to the internet. You wouldn't be able to do anything useful at all, for the most part. Dangerous is good. Dangerous is the whole point. That's why we write code. But how often do you really think of it like that? When you're writing an application, you are your code sandbox. You control everything that happens. If you want to write to the file system, you do so precisely when and where you want. You only delete the files that you want to delete. You control everything that happens. That's why you don't usually care about sandboxing. And plus, we almost never need or want to allow anybody but us to evaluate code on our machines. It just isn't something a lot of programs require. Thing is, Clojure makes it really easy to get code from, arbitrary sources and evaluate it. Like in this example, we call the reader to get code from a string. Stuart Sierra's talk was actually a great prerequisite to this. And then we call the compiler at runtime to evaluate that code. It's that easy to do that. But what about situations like this, where, like LazyBot on IRC, if you evaluate something like system exit, you kill him. If he doesn't have any protection against that, he dies. It's that simple. And it gets worse. What if you delete a file? You could just delete files on in his home directory. It's that easy. Something has to be done about this. So we need a sandbox to keep us safe. A sandbox can prevent input and output, interaction with the file system, interaction with the internet, prevents the execution of arbitrary programs, and it prevents destruction of the JVM, like with the system exit call we did earlier. We got to stop things like that from happening. So, the great thing is that the JVM actually has a built-in security architecture. It is very thorough. It's been around since before I learned to walk. It was introduced in the first release of Java back in 1995, I believe. I was 1 year old. So yeah, it's great. It's mature. It denies access to certain methods and classes, prevents input and output if you want it to, and it's customizable. You can pick, mix and match what you want to allow and not allow. Basically, it stops this stuff from happening. No system exits. Stuff like this, you won't be able to slurp anything, talk to the internet here. You won't be able to read from the file system unless you explicitly tell it you want it to be able to read from the file system. Given just basic permissions, it'll prevent almost anything that can cause problems. It saves your computer from evil. Unfortunately, it isn't quite enough for every single use case. Clojure. The hardest part of sandboxing Clojure isn't sandboxing the JVM, since the JVM can fend for itself. The hardest part is sandboxing the state of Clojure itself at any given time, like the namespace, things like that. For example, what if they rebind things? If they rebind plus to minus, it's gone. It's plus is minus. And what if they execute an infinite loop in your sandbox? They'll lock it up. Nothing's going to stop that. There are a couple of services right now that face these problems. Try Clojure, For Clojure, and LazyBot, which is a REPL for your IRC channel. It's in the Clojure IRC channel. You've probably used it. If not, you should. We'll talk about all these things later. They all take different approaches to sandboxing, and we can investigate those and learn from them. Wow. See, I edited that this morning, like 2 minutes after I woke up. So, yeah. I think you get the point, though. So, I'm not going to stop and go back to my room and fix it. So what we need to do is we need to rip apart code. We need to look at namespaces. We need to look at symbols, classes, packages, vars, and anything else we can get our hands on. We need to check all those things. We need to keep defs from being abused because, of course, you can rebind things in the namespace, and they can be used to abuse memory. Giving a person the ability to def things means they can def something in the sandbox namespace that has the same name as something in Clojure.core or another namespace. They can basically ruin the state of the sandbox namespace with it. If you allow def and everybody uses the same namespace, then it can get corrupt. Furthermore, if allowed, they can use it to hold things in memory that shouldn't be held there. And infinite loops. We need to simply time those out. We need to prevent long-running operations from taking too long. We need to prevent things like range 1 million and infinite loops. And threads can be used inside of the sandbox to avoid timeouts. So we have to do something about those too. We need to kill them to make sure they aren't used to get past the sandbox timeouts, because it can only kill the top level thread once the timeout is over, or the timeout's up. And we need to do something about Clojure's Java classes. The JVM sandbox can prevent access to classes and methods that can damage the system and the JVM itself, but it can't really do anything against Clojure's own Java classes. They can be used to do stuff like the intern here, which can corrupt the sandbox namespace. The JVM sandbox is only concerned with input and output in the JVM itself, not with overriding defs in a Clojure namespace. So Clojure's Java classes need to be sandboxed in some way. Furthermore, we can't get rid of dot. Java interop is a huge part of Clojure, and eliminating it means eliminating one of the most useful properties of Clojure. We also can't just rebind it because it's a special form and you can't rebind those. Instead, we need to be clever and actually replace the symbol in code before we evaluate it. And we'll talk about that shortly. So that's what's needed to make it safe, but we don't really have to stop there. We can do more with this. We can make it pretty extensible, because safety isn't the only concern. We can have customized evaluation contexts. For example, if you only want to block the map function, then you can do that. It doesn't have to only be things that are inherently unsafe. It can be anything you want to block. Clojure is actually built on this, because some of the problems involve re-implementing core functions, and they have to block those core functions from being used because you could be using the cheat. So Clojail. It is an all-you-can-eat sandboxing library written by this guy and this guy, inspired by ideas from this guy, licensor. You probably don't, I don't know if you recognize him or not. He ain't been around lately. Sadly, I miss him. Which were inspired by an IRC bot from this guy, Clojure bot, for you guys. It can take advantage of the JVM sandbox. It sandboxes the Clojure side of things, like sandboxing defs and preventing infinite loops and things like that. And it does you can do very selective blacklisting, like with the customized evaluation context, like we were talking about before. It basically does everything we've talked about. So here's how you use it: lining in or cake, whatever build tool you're into. The current stable version is 0.5.0, which I released specifically for this conference. You can all thank me later. And here is an example sandbox. This sandbox does not actually block anything. You can see that we passed an empty set to the sandbox function. Normally this set would be our blacklist. Right now we're not blacklisting anything. So if we evaluate 3 plus 3, we get that back. However, even though we didn't block anything on the Clojure side, the JVM sandbox is still enabled by default. So even though we didn't block anything, if you try to execute system exit, it won't let you do that. We can explicitly disable the JVM sandbox if you really, really want to. I wouldn't advise it, by passing the keyword argument JVM false. Sandbox takes a set of things like classes, packages, symbols, sets, and namespaces. Pretty much any object that can be printed to a string and read back again. Like I said, Stuart Sierra's talk was an excellent prerequisite for this. This is because we embed the tester in our dot replacement macro, but we'll get to that later. It's kind of complicated. No, it's very complicated. I hate it. So, like I said before, you can block only the things you want. In this example, we have a sandbox that only blacklists plus, minus, and the entire Java math class. If we try to use any of those things, the sandbox gets angry, complains. So, but you don't really want to be concerned with finding every single thing that can mess up that needs to be sandboxed. It's unsafe. So, I'm trying to do that for you. We're trying to do that for you. So we have a tester's namespace that contains pre-made testers, pre-made sets of things that we found that can be used to abuse the sandbox. The most important one is secure tester, which is a tester that blocks a lot of unsafe things. We add to it over time. So you don't really want to depend on it being completely safe, but if you find any problems with it, you want to report those, and then we'll fix it, and if there's anything that needs to be added to the secure tester, we'll add them. But it's safe enough that, we can use it in IRC and LazyBot and things like that, and we rarely have problems. People have to actively look for problems. They don't accidentally stumble upon them. These days, anyway. Took a while to get here. You can also do fairly dynamic sandboxing. There's Sandbox Star, not to be confused with Sandbox. This one is the same as Sandbox without the star, but you pass the tester in when you evaluate the code every time. That way you can switch the tester and still keep the same namespace. Sandbox without the star is actually just a simple wrapper function around Sandbox Star. All it does is it partially applies the tester that you pass it to the function that Sandbox Star returns. That way you don't have to pass it every time. Sometimes you don't need to, and it's easier. But other than that, they both take the same arguments, of which there are a lot. Wait till you see the argument list. I'm serious. It's bad. The sandbox automatically destroys long-running operations, like this infinite loop here. After 10 seconds, it times out. You can set the timeout by passing the timeout keyword argument. Like in this example, we're setting it to 5,000 milliseconds, which is 5 seconds. So in the next example, it would time out after 5 seconds. I can't really demonstrate that in a slide, but you get it. So we also do some creative things with defs. To allow def, we have a extra tester in Clojail.tester. It's called Secure Tester Without Def, because I couldn't think of a longer name that made sense. Basically, it's just the same thing as Secure Tester, only it throws def on the end so that it's allowed, because only recently we started doing things, things with def to make them somewhat safer. Like in this, old defs are wiped once they exceed whatever max def is set to, which is 5 by default. That means they are undeffed, unmapped. Here we def 6 different things in a row. We do each of them one at a time. Once we get to F, the sandbox realizes we have def more than 5 things, which is what max defs is set to by default, and so it undefs all of those previous defs. That's a lot of defs. The latest one, F, is allowed to remain. That's why we can still use it. The newest batch of defs is also undeffed if it exceeds that number as well. For example, here we're defining 6 defs all at one time in the same block of code, the same evaluation. The sandbox realizes what has happened, and it wipes them all immediately. That prevents people from creating a whole bunch of defs in one single batch. Each sandbox gets its own namespace. When you create a sandbox, it creates a new namespace. By default, the namespace is just a gensim with sandbox at the end, or prefixed, not at the end. You can set what the namespace is by passing the namespace key. It could be a symbol or a string or anything. Yeah, it can't be anything, obviously, but a symbol or a string. So Clojail actually has a mini... Turn your phone off. That's rude. So Clojail actually has a mini library for working with the JVM sandbox. A lot of this code was actually taken from Clojure and put into CLJ Sandbox, which is what Clojail pretty much evolved from. It was written by Hines, licensor. Don't know how to pronounce his last name, so I'm not going to try. Anyway, this code was adapted from Clojurebot's code to be more library-like because it was, it was for Clojurebot. So we have this little library for working with the JVM sandbox that is completely separate from the Clojail.core. It works all by itself if you want it to. So in this example, we're defining a security context that allows an extra permission here. A file permission. We're giving the sandbox the ability to read and write to a file called foo. Normally you wouldn't have this ability. So we can use this context instead of the default context, which just allows you to access declared members. And we pass it to sandbox with the context key. That said, you don't have to use the Clojail part of things. You don't have to, it's all in Clojail, but you don't have to use the Clojail.core part of things. You don't have to sandbox Clojure at all or even touch Clojure. You can just call JVM sandbox, which is actually just in Clojail.jvm, and use it if you don't want the Clojail.core part of things. It works completely as a standalone library, and like I said, it's integrated into Clojail's other things if you want those. It could actually become a separate library at some point if people find it useful enough alone to warrant taking it out. But for now, it makes sense just to stay in there. So you can pass init code to the init key. This code is code that will be executed in the context of the sandbox namespace, but outside of any actual sandboxing. That means that even if you don't allow def, you can pass code that uses def, and that'll happen as soon as you create the sandbox. Like right here, that would happen immediately, and then foo would be available in the sandbox namespace when you evaluate code in it later. Any defs that occur in that never get undef. We already talked about how we undef things after a certain amount of defs have happened. Any defs that occur there are considered special, and they never get undef. It's great for setting up a sandbox namespace with standard defs and imports, depending on what your program is actually using Clojail for. I'll actually show you a usage of it in a little while when we talk about Clojure. You can also pass bindings, like binding, like the binding macro. You pass stuff like this. You can bind an out to a string writer, and then if you print anything inside the sandbox, it'll go to the writer. And basically just a shortcut to using binding. So that's Clojail. But you're Clojurians, and you probably want to know how all that works. Some of you might want to leave the room now. So let's look at the individual pieces that make up the sandbox, starting with check form. This is what checks for bad stuff in our non-interop code. It calls separate to explode your code, then checks if any of the results are in tester. If any are, then the code is bad. Now the actual exploding. What we do here is we macro expand most of the code. What macro expand most does is it's basically macro expand all, with the exception that it doesn't macro expand things that begin with a quote. Next, we ensure it's a collection with qualify, which is a great name. I'm not sure if I named that or if Alan named that. But it's wonderful anyway. I don't care what anybody says. And all it does is if what's passed to it is a collection, then it just returns a collection. Otherwise, it wraps it in a collection. It's not important. And then we call flatten all. Flatten all is just like the core flatten, only it actually works. The core flatten function doesn't flatten maps, and we need that to happen, so we can't use it. So we just wrote this simple flatten all. Alan wrote it. It just uses a tree seek. It's pretty nice. Check it out. So next we check each object that's passed to see if it's a symbol. If so, we try to resolve it and get its meta. If it has meta, we yield the resolved object. We yield its namespace, its name, and namespace is a symbol, if we can. And I know, you're probably thinking that the juxt was actually written by Alan, but no, that one was me. Okay. If you've ever talked to him in the IRC channel, you know what I'm talking about. He's nuts for juxt. So if it is a symbol but doesn't resolve to something with metadata, we split the symbol at the slash and try to, it's qualified, and try to resolve the part before the slash. If it resolves to a class, we yield it and the original symbol. Otherwise, if none of that applies, we just yield the symbol itself. Finally, if what was passed was not a symbol at all, if what we're at in the code is not a symbol at all, then we just yield the object that was passed, and we assume that the tester might look for that. We just have to basically do special things for symbols to make sure that we can check every part of a symbol and everything that it could be. So this all results in a huge set of objects, symbols, classes, and anything else that was in our code, and we can run our tester against that with check form. And that's how we find out if something that's blacklisted is blacklisted, or something that's blacklisted is in the code or not. So that's how your non-interop code is handled. But what about your Java interop code? Clojail actually sandboxes in 2 stages. The first stage is that it checks the code before evaluation. We just talked about that. We checked the code with check form, and we exploded it with separate and all that good stuff. The second stage is that it modifies the code itself before evaluation so that it can sandbox things that couldn't be checked or it could have missed before evaluation, or if we just need to do something before we evaluate it to replace things that are unsafe with safer alternatives. The primary example here is with the dot special form. So what we do with dot is we have our own specialized dot macro that runs the tester against the object and the class and everything like that. And we replace the dot special form in the code, the dot symbol, we replace it with a symbol for our dot macro. This is just a simple recursive walk that replaces everything. That's what dot actually does. It's interesting here. So this function returns a dot macro definition. I know it's lovely. That uses our tester to check for evil. It'll be evaluated inside of the sandbox. You'll see that in a minute. Note that it takes the tester as a string as an argument. The tester is embedded in the macro, which is why we need it to be possible to print the tester to a string. Because it's embedded in them. Yeah. Like I said, his talk was great for this. All it really does is check if the object, object's class, or object's package are in the tester, and if so, we throw a security exception. Otherwise, we evaluate as normal. That's all you really need to know about this. I wouldn't look into it too hard. We try not to. It's scary, looks horrible, so let's move on. And that's how dot is handled. But what about timeouts? this is thunk timeout. This was also originally from Clojure bot, but it has been changed. Let's just say it's been changed significantly. It has a bunch of arities because it has, a bunch of arguments. Well, I guess it's only 4, but let's consider that a bunch. Anyway, it has a bunch of arities to pass defaults for its arguments, but I've cut those out because these slides are only so big. And what it does is it runs a future task in a thread, possibly in a thread group if one was passed, and it gives it a certain amount of time to do its thing. If it takes too long, it cancels the task, or if an exception is thrown inside the task, it cancels it and stops the thread. And it always, no matter what happens, it always stops the thread group if one has been passed, if a thread group's been passed. So, the thing about sandboxing threads is it's kind of interesting here. We can use a thread group. We can run our thunk timeout inside of a thread group. And then any thread that the code that we're sandboxing creates will run inside of this thread group. But that does not apply for things that use thread pools, like futures and agents and anything else in Clojure that uses thread pools. Killing the thread group would not kill those things. So until we get more clever and figure out a way to handle thread pools, we have to not allow futures, agents, and other things that use thread pools because they can be used to spin off threads that we can't kill. So here's the part of things that actually evaluates your code. It's a function that returns a function that we pass to thunk timeout. That's what we pass to it. Basically what it does is in the context of the sandbox namespace, we evaluate our dot macro, like we talked about before, and our modified code under the JVM sandbox with whatever bindings were passed. So that's a lot to take in. So here's how Clojail puts all that together with the sandbox star function. Now everybody be careful. This might hurt a little bit. And if that code is too small, I tried everything imaginable to make it fit in the slide and be big enough for you people to read. Anyway, that was without the doc string. The doc string is longer than the code. The argument list is half of it. It's basically all of its arguments are keyword arguments, so we just create sane defaults for them here. First thing it does is it binds star and s star to a new namespace that we create on the fly. If the users pass the refer Clojure keyword argument and set it to false, then we do not refer Clojure. By default, refer Clojure is set to true. And if it's set to true, then we automatically refer Clojure inside of this namespace. That sets it up with clojure.core, just like you'd expect any normal namespace to start up with. But you can pass it as false to do that stuff yourself if you have a very specialized way you want to set it up. And that's the next thing we do. We evaluate init. It evaluates this code inside of the sandbox namespace, but as promised, it's actually outside of any sandboxing, so anything can happen here. But if you pass refer Clojure false, you're expected to set up the namespace in the code you passed to init. You can do whatever you want. Okay, so the next thing we do is we get everything that is currently defined in this new namespace, and we bind it to the name init-def inside of a let. Also included in this list is dot, our dot special form replacement macro. We'll check this later to find out what we should undef and what we shouldn't undef, since we don't ever want to undef anything that was defined with the init keyword argument, and we don't want to waste time undefing our dot macro. So this is the start of the function that the sandbox returns. This is what you've been creating and using to evaluate your code in our previous sandboxing examples. Notice that it takes a tester argument here. Like I said before, if you use the sandbox without the sandbox without the star wrapper function, you don't have to pass the tester. But if you want, you can just call sandbox star and pass the tester every time you evaluate something. Because this is the function that you call to evaluate your code. It's the function that sandbox star and sandbox returns. So the next thing we do is we bind tester str to a string version of our tester. This string was produced by printing the tester to a string with print dupe set to true. I love you, Stuart Sierra. Thank you for your talk. They would not know what I'm talking about right now if it wasn't for you. They probably still don't, but I'm trying. We have defined an implementation of print dupe for Java packages so that we can embed them in our dot macro if they are contained in the set. That's the main thing. We need to be able to, any object that goes in this needs to be able to be printed. So one big part of sandboxing is that a lot of the time you want to blacklist entire Java packages like java.reflect. I think that's one of them. Something like that anyway. But so we have a special print method for that. Print method? Isn't it print method? I think it's a print method. Print method for that. And as long as the JVM keyword argument hasn't been set to false, we enable the Java Security Manager. This enables the JVM sandbox for when we evaluate our code with our mini JVM sandbox library. You almost always want that. So next, in a try block, we use the check form function to check for evil code, like we talked about before. If evil code is present, we throw a security exception. Otherwise, we evaluate the code with our evaluator function, wrapped in a timeout so that our code times out and throws an exception if it takes too long to execute. And I'm out of water. That sucks. Finally, we call white defs to manage the things that are currently defined in the namespace. This is all just fairly uninteresting logic, but what it essentially does is it looks at what was defined when the namespace was initiated with, anything that was defined with the init key. And it takes those things out of the equation so that they can't be undeffed, because we don't want to undef those. It then looks at things that were defined in previous evaluations and it counts them, undefining them if they exceed whatever the maximum number of defs allowed is set to. Finally, it checks what was defined in this particular evaluation, counts them, and undefines those as well if they exceed that number. So that's how all that stuff is handled, but it's uninteresting, and this talk is already too long. This is slide 99. I think I've got the longest talk so far. The longest, number of slides, anyway. So the result of that is a Clojure sandbox. It's awesome and all, but we got to think about a few things here before we use it. If being safe is important, you should take every precaution imaginable. The JVM sandbox is mature and thorough, but that doesn't mean that it's invincible. They spin around forever, like I said before I could walk. They still find security problems every now and then. It's understandable. This stuff is hard. It's really very hard. So you want to put some effort into sandboxing the code at the OS level. Thank you. You want to put some effort into sandboxing the code at the operating system level as well as at the application level. For example, you could run your code in its own user account. I mean, that doesn't stop everything, but just whatever precautions you can take if you really, really need your machine to be safe and you're evaluating other people's code. You don't know what these people are going to do. You people are insane. You've proven that to me so many times since we started this library. Anyway, you're okay as long as you use the JVM sandbox. For the most part, if you take advantage of that, your computer is as safe as a JVM can possibly make it. The safety of your computer is not really a concern. If the JVM sandbox is enabled, the worst that can happen usually is an infinite loop where you run out of memory. And that's if Clojail itself fails. Allowing everyone to safely evaluate code in the same namespace is Clojail's primary goal. But that is a goal, and thus what we're working towards, and not necessarily what we've completely accomplished. We still find holes sometimes, and when we do, we fix those. The thing is, we can't test every possible scenario. We can only find things and fix them as we go along. It grows over time. We are limited by not being rich hickey and thus not knowing about every single thing in Clojure that can break the sandbox. I'm sure he's sitting over there right now with about 20 things that he just dying to throw at it. And that's good. Clojurians are drawn to sandboxes. They are drawn to them. They want to destroy them. Every time I mention Clojail in the IRC channel, someone starts trying to break LazyBot. Every single time, without a doubt. They try to break it every time. And I mean, that's great. I encourage people to do that. Just, if you do break it, tell me about it. A lot of people don't do that. They break it and they're like, oh, awesome, I'm great. I'm cool. I broke this. Then I can't fix it if you don't tell me what it is. So, but people, mostly me, trust Clojail enough to use it in their own projects. So here are a few examples of that. I still have a little bit of time. I might have to skip the last one. Try Clojure. It's an interactive tutorial website for Clojure with a Clojail-powered REPL that evaluates code on the server side. It's similar in nature to the other tri-language websites like Try Haskell, but it has a space in the name, and I think that makes it cooler. It's built on Chris Granger's awesome Nuwa web framework, and I pronounced that right. It runs on Heroku, which also makes it cooler. I bet Phil will like that. Here's a screenshot of it in action. So the approach it takes is that def is allowed and every user has his own namespace. Timeouts happen very fast. It tries to emulate a REPL as closely as possible. Since each user has his own namespace, allowing def isn't really that big of a deal, because if they screw up their own namespace, why do we care? So here's the code that it uses. It creates a sandbox with a tester that is a secure tester without def, and also blacklists tryclojure.core, so you don't try to get clever and screw something up in the actual core of the website. And we use the init keyword argument to provide code that removes the sandbox namespace after 10 minutes. That's pretty self-contained. When an eval request is received, we check if the user has a sandbox in their session, and if so, we use it. Otherwise, we create a new one and store it in the session. Sessions expire after 10 minutes, so after 10 minutes, the idea is that anything that anybody's done is gone. They were never there. Credits for that go to Andrew Gashevitz. He designed the whole thing. The lovely design that's there now. I'm sure some of you have seen what it was before when I designed it. Wasn't worth using. And got to thank Chris Dunn for his awesome jQuery console he used for the REPL interface. And the design is actually inspired by Try Haskell. And we got to thank Alan Johnson, Mephisto, because he wrote the interactive tutorial. All right, I think we have time for one more example here. We're going to skip LazyBot, because everybody knows about it. Foreclosure is the most interesting Clojail use case. You solve cone-like Clojure problems and tasks in your browser. It has a long list of problems of variable difficulty, ranging from easy to very hard. It's wonderful as a companion to any Clojure learning material. It's great for even people who have been using Clojure for years because it has hard problems that can really challenge you. Here's a screenshot of that. The approach it takes is that it relies on dynamic sandboxing. If a problem calls for the reimplementation of a core function, the core function or similar functions can be blacklisted to prevent cheating. Here's the core code that it uses to sandbox. For every test in the problem, every test case, it replaces the 2 underscores with the user's code, and then it evaluates it in the tester. It's actually pretty simple, but it's a great concept. So the credits for that go to David Byrne, Alan Malloy, Alex McNamara, and Karen Meyer. She did a lot of the front-end stuff, made it look pretty, made it work. And, well, let's skip this for now. it's not important. LazyBot sucks. Everyone knows that. Okay, so here is the last slide, I promise. Don't get paranoid. Here's some guidelines for using Clojail in your own code. The JVM sandbox is your friend. Always use it. It'll keep you safe. You want to follow Clojail's release cycle as closely as possible and update it every convenient chance. Anytime it's updated, it means we fixed something or made something better, and you want to have that in your code as soon as possible. Don't be paranoid. Remember that the JVM sandbox will protect you from real danger. And if you avoid sharing the same namespace with everybody, it's much less likely that one person will blow away the state of the entire application, the entire sandbox, for one person, for everybody. I mean, you don't want to allow death and give everyone the same namespace, because if you do that, they will corrupt the namespace and screw it up for everybody. And I got a couple of links up on the Clojail wiki to documentation on the JVM sandbox itself, not Clojail. It's actually pretty interesting. The JVM security architecture is really, really complex and thorough, like I said before. So if you're interested in the JVM sandbox itself, it's pretty interesting. There's a couple of links there, and I'll put some more up there when I find them. So here's my thanks, but I don't actually have time to say them, so read them, and that's it.